So what we are going to do today is basically play with R and Hadoop. Okay, and as we mentioned yesterday, the primary goal of that is essentially to enable data scientists to write R code, but still make it scalable. Okay, because by default R code cannot be run in a cluster, especially on Hadoop, for example. So how can you make that happen? And that's the goal of these packages. Okay, so we'll first see why there's R and Hadoop, R plus Hadoop, and different ways of integrating it. And then we'll look at multiple examples on the VM. Okay. Okay. So I guess the motivation is not required, I think, because I'm sure you guys agree with this, that R is limited to one machine, and how can we scale it up? Only go to the multiple machines, and we have Hadoop already as almost like a de facto standard for distributed computing nowadays. So using R with Hadoop, you can kind of get all the benefits of Hadoop while being in R environment. Okay. So, okay, there are different ways of integrating R and Hadoop. All of them at high level. Yes, main gain is horizontal scalability. Okay. So different ways of integrating with R and Hadoop. So the first one is something called as R Hadoop packages. Okay. And these packages are developed by a company called Revolution Analytics, and this is currently the most popular way of doing R and Hadoop integration. Okay, and we are going to look at those things as well. And there is using Hadoop Streaming. I will tell you what Hadoop Streaming is, because our Hadoop packages actually leverage this particular feature. Okay, what that is essentially Hadoop Streaming allows you to write your mappers and reducers in any language. Okay, so like if you are a fan of Python, you can write your map and reduce. I mean, there's already PyHadoop, which is kind of using that feature of Hadoop Streaming, but the core concept is, or if you are a fan of Ruby, okay, Ruby Rails language, you can write your mapper and reduce function in your language of preference, in this case Ruby, and then I can run it in the mapper and reduce, I mean, like a map reduce job using Hadoop Streaming. We will see how that is done actually. Okay, so for now just keep it on the side. Okay, and this one, the repay, is actually the first method that came into existence. Okay, first method for R and Hadoop integration, and this was developed by one of the student at his university. And if I'm not wrong, this is a guy who, after his study, he went and joined Revolution Analytics and made or kickstarted the process of R Hadoop. I think, I may be wrong, but I remember reading about that. Okay, so primarily we are going to look at these things: R Hadoop packages, which is developed by Revolution Analytics company. Okay. And what are they? Primarily, oh, by the way, did you guys get to install Hadoop and these packages at all? You can download these packages from R Hadoop at this website, github.com/revolution analytics. They are open source. I mean, these packages are open source, but R Hadoop has some other features which are not R Hadoop. Revolution Analytics, apart from these 3 packages, they also have a couple of others which are again geared towards R and Hadoop integration, and they're not open source. Okay, but these 3 at least are easily downloadable from web and install it. Okay, so first one is called RMR. R MapReduce. Okay, it's basically for interface for running MapReduce jobs using R. Okay, and RHbase is an interface for reading and writing and manipulating data with HBase. Okay, and RHDFS, of course, it's an interface to HDFS. Okay, that means you can interact with HDFS from R. What can you do by interacting with HDFS? You can actually, I mean, simple things like you do in any file system, right? You open a file, you close a file, you remove a file, you add a file, those kind of things. Okay. So for each of those things, you have capability in RHDFS. Okay. So these 3 are the main packages, and we are going to focus in this particular class primarily on RHDFS and RMR. Okay, so we are going to learn how to interface with the HDFS as well as how to write MapReduce code using RMR. Okay, so this is fine. Yeah, so RMR is actually an older version of the package. Currently, when you go there, you will see actually something called as RMR2, which is a recent version of the package. Okay, we'll get to these things a little later. Yeah, RHDFS. As we said, I mean, what can you do with the function, right? Simple file manipulation and standard file system commands, right? So, for example, you can access HDFS from R, meaning I can be in my R Studio or R client, meaning R console, and I can connect to HDFS and read the data from HDFS and create a data frame out of it in my client, assuming the data is small. Okay, if the data is large, then I cannot simply access it and load it as a data frame, obviously, because I'll run out of memory. Okay, so read from HDFS to R into a data frame, that's fine too. And obviously you can write from R to HDFS as well. Okay, both ways. So there was one. Okay, so these are all different. Oh, actually, let's see some examples and then come there. Okay, so these are some of the common functions in Hadoop file system API, right? One is just simply listing of all files in Hadoop. Okay, are you guys familiar with these commands? Probably not all of you, right? Since No, okay, cool. Yeah, very much like Linux commands, right? I mean, all you need to do is put Hadoop FS in the middle, in the beginning, and then put a hyphen that tells you the actual command. Okay. I mean, even if you don't know, it's pretty straightforward. So here I'm listing all the files and directories under the path /. Okay. So this is a usual Hadoop command that you would give on the command line in order to list all the files, and the same thing can be done from R via a function called HDFS.ls. Okay, assuming that you imported the RHDFS package, and similarly you can create a directory using -make mkdir. This would be the Hadoop command line thing that you would use, and the same thing you can do from R by calling hdfs.mkdir. And similarly, this is for putting a file from local file system to Hadoop file system, and getting a file which is Hadoop file system to local file system. Okay. And there are multiple ways to do those things. We'll see those examples, and then of course you can delete a file as well. Overall, these are all the functions that you have in RHDFS. Okay, first ones are basic file manipulations, like copying a file, moving a file from one location to the other location on HDFS. Renaming is similar. And then delete a file, delete a directory, change the ownership of the file, put and get. So those are all the basic file manipulation. And of course you have file read and write, okay? And you have like a metadata operations, whether to check something is a directory or not, create a directory, listing of all the files, checking if something exists or not, and then some initialization methods. Okay, so I mean, there's nothing fancy here, right? These are just the basic capabilities of any file system, and you simply have a handle to those capabilities from R. Okay, that's all it matters. Okay, any questions? So Patanjali says Hadoop FS -ls -ltr. Are you sure that LTR is supported in Hadoop? I didn't know. I never did. I mean, of course, I never tried, but I. Oh, okay. Yeah, I don't think so. Oh, okay, okay. You're just referring to the fact that they're similar. Okay. Yeah, I mean, not all the Unix commands work in this Hadoop fashion, obviously, but yeah, nevertheless. Okay, so that's all about RHDFS actually. I mean, in terms of slides, I mean, that's all we can see. We will see examples on the VM later, but from understanding purposes, that's all is there for RHDFS. Okay. If there are no questions, I'll go to the RMR thing, and then we'll finally go to VM and then look at different examples. Okay, so let's go to RMR. Okay, so what does RMR provides? RMR or RMR2 to be specific. What does it provide? It enables you to write MapReduce jobs in R and then obviously get it executed on the Hadoop. Okay. So what do we mean by write MapReduce jobs in R? It essentially means you are still in the MapReduce framework. So while coding, you are still in the frame of writing mappers, reducers, and all that. However, instead of writing in Java, you would be able to write in R. That's the only difference. So we have seen how to create functions in R, right? Like for classification, for example, we created a function that checks that computes different classifier performance measures, right? So in a similar manner, you would create another function called myMap, and then it takes a key value pair, okay, and it outputs a bunch of other key value pairs, right? Because that's what we said is a mapper, right? Mapper takes a key value pair and then produces a list of key value pairs. And in a similar manner, I'm going to write R function called myMap, which exactly takes a key value pair and then produces a list of key value pairs. Okay? That's all I need to make sure that function does. And as long as it has such an input and output characteristics, I can simply use it, use that function in the place of a map. Okay? And similarly, what does reduce do? Given for a key, given a list of values, right? You do some aggregations inside the reduce and then produce another list of key value pairs, right? And the same thing you can do in R as well. So you write a function called myReduce, which has exactly the same semantics, and then you can call that function from the reduce phase. Okay. So by doing this, essentially you are able to run your programs on large data. Okay. Without these capabilities, what you had to do probably is either don't deal with the data at all because it's large, or you can simply sample a small subset so that it fits in your memory and then work with it. Okay. But that's if you don't have RMR2. Okay. And RMR2 enables you to execute one function called as MapReduce. Okay, this is an R function. So you call MapReduce function. It internally spawns a MapReduce job to get your work done. Okay, so that means this is a primary, the single workhorse for you for doing anything. Okay, so whenever you want to run a MapReduce job, you would call MapReduce function in RMR2. Okay, and what does this function take? Not surprisingly, I mean, if you think about it, you can list those things as well. What should a MapReduce job have at the minimum? It needs to have an input data set, right? Because you need to operate on some data. And then you will produce some other data as part of your MapReduce job. So you need an output path as well, where the data should go, whatever is the generated data. And then obviously at the minimum you should have what is your map function, what is your reduce function. Okay, and there are a bunch of other options as well, we'll see. But at the minimum, these are the main stuff, right? And yeah, the latest versions also have support for Microsoft Hadoop distributions as well for Windows, but that's okay for now. Okay. Okay, so these are the functionalities provided in RMR. pretty straightforward. And yeah, do you guys have any questions here? I mean, obviously you will gain much better understanding when we see examples. But before we go there, I thought of just getting these slides out of our way. Okay, so with such a RMR capability, you would get essentially well-designed API, flexible I/O subsystem, meaning you can read from any arbitrary thing as long as you create appropriate make input format. Okay, and you can create MapReduce jobs, and then you can also run it on the local backend. So we'll get to see this one later. Actually, I don't want to confuse right now. Okay, so that's all about RMR2 also. Actually, pretty simple, right? Any questions that you have? Okay, so let's open up a VM where I have my Hadoop installed, as well as all these packages I set it up. We'll open the VM. We'll first look at some examples of our HDFS. Okay, like copying the data, reading the data, deleting data file from HDFS, those kind of commands from our HDFS package. Okay, so we are going to do them, and then subsequently we will look at different MapReduce jobs written in R. Okay. Great. So let me open up my VM. Just hold on. If you guys already have yours, you can do the same, especially if you want to try out examples on the side as we speak. Okay, so give me 1 minute. I'll start my VM. Okay, just hold on, guys. It's coming up. One second. Okay, so I have my VM here. Are you guys able to see? So this is Cloudera VM that you guys probably have downloaded as well, right? This is slightly older version, 4.4.0, but the newer version is also fine. Actually, later for Mahout, I'm going to use a newer version because my R Hadoop setting is not there in the newer version yet. So that's why I'm just using the older one. Okay. Okay. So for people who are new to MapReduce, so yesterday we talked about job tracker and the name node, right? So when you install Cloudera VM, you would get those things as well. So this is how the job tracker would look like, which basically tracks all the jobs, right? It tells you how many nodes you have. Since it's a VM, I just have single node, okay? How many nodes you have, how many map task capacity that is there in your cluster, how many reduced tasks are there, total number of submissions to this job tracker so far, and these are the list of jobs. Okay, so as your program is running, you can see your jobs under the running jobs heading. You can monitor them, you can do a lot of things. Okay, so that's the interface to the job tracker, which essentially lets you kind of view the list of all the jobs that are running in the cluster. Okay, and similarly there is a name node as well. Okay, okay, actually, yeah, it looks like that. So where it says how much total memory available for HDFS, how much of it is used, how much is available, if there's any corrupt blocks of data or missing blocks of data, how many nodes are there again. Here nodes meaning how many data nodes are there. Okay, and yeah, and then you can also have so there is this link called browse the file system. So you can browse the Hadoop file system from the browser. So if I click on this, I have, for example, under the root directory, I have a bunch of folders. Let's say user Cloudera, and these are all my data files that I copied onto HDFS, or I created them as part of some MapReduce jobs or something. Okay, but it's essentially the interface to API name node. Okay, so those two are job tracker and the name node, which are common for any MapReduce distribution. Okay, nothing about Cloudera, nothing about R and Hadoop, anything like that. Okay, so obviously we want to run our R program, right? That means we need RStudio even here as well. So, I mean, this is Linux, it's a different operating system, but you can install your RStudio on this operating system as well. So if you go to our website and look at the downloads, there'll be one version for Linux. Okay, so let's say I installed it and I am simply running it from the command line in the background mode because I'm going to be on it for quite some time. So when I open RStudio, I get this RStudio, just like the one that we see on Windows. It's exactly the same thing, right? You have a location where you can write your commands or write your script, and this is our console that we all familiar with, right? And then this is a help file, there is a history and all the usual things. So this is exactly like the RStudio that we see on Windows, but it's now running in Linux. Okay. Okay. So now let's start by playing with our HDFS. Okay, and then we'll subsequently in the second half of the class we'll look at different MapReduce jobs. Okay. Okay, if I have maximization, then I cannot see the questions. So let me remove maximization here. Okay, so Debojyoti says, do we have options to check job status from terminal as well? Job status, you can look at all the running jobs, you can kill jobs from the command line, and yes, there will be multiple things that you can do from here if you do. Okay, let me increase the font before I do anything. Okay, so there's a Hadoop job API, and it has all these things. You can submit something, you can check the status, you can get the counters, you can kill something, you can list all the jobs that are running. So these are the things that you can do from command line or from terminal. Okay. Does that answer your question, Debojyoti? Okay, great. So, okay, let's go back to our R Studio. So what did we say these R Hadoop are? RHDFS, RMR2, RHbase, these are all R packages, right? Just exactly like the package that we have seen for Naive and blah. We have simply new packages. And how would you install new packages? Usually from install.packages, right? So we would usually call, oh, where am I typing? Install.packages and then our package name, right? This is how we used to install. And what does it do? It simply connects to this CRAN repository, right? We talked about CRAN, where all the packages are hosted. It connects to CRAN repository, downloads that package, and compiles it onto your machine if they are in source code format. Okay? But however, our Hadoop packages are not in CRAN repository. Okay, they are available in the different location that I mentioned, GitHub. They are not part of CRAN repository yet. Okay, so you cannot install them via install.packages. Instead, you install it on the Unix command line by following certain method, and you can see those instructions on LMS. Okay. So that means install is happening outside of our studio. But once the installation is over, what did we say how to load a particular package? We simply call library and name of the package, right? So this will load the pre-compiled version of the library on your machine. It will load it into our studio. Okay, so this is exactly the same thing. So if I want to load our HBase or our HDFS, I simply have to say our HDFS here. Oops. Okay, so that will load our package for HDFS. So I already had installed it, so that's why the load finished successfully. Okay, similarly I can do RMR2 as well. Okay, it loads a bunch of other dependency packages, but ultimately we get our command line back. That means this particular function has finished successfully. Okay, so that's the same thing that you do with any package, any R package, right? You would do the same thing. So, okay, once you have it, you can now start using all the functions that are available in HDFS, RHDFS package, right? the ones that we saw on the slide: basic file manipulation, reading and writing of data, interacting with different directories and stuff like that. So we are going to now see some examples of those functions. And meanwhile, there's a question here. Patanjali asked, do we have to manually install RStudio in the VM? Absolutely, yes, because VM does not come with RStudio by default. Okay, so that's something that you need to install on your machine explicitly. Okay, is that all the question, or did you have anything more? Because it sounded like you had something in. Okay, so let's work with RHDFS, right? So let's say we install it, and I simply call library. It will load the package. Oops, are you guys able to see the screen and hear me? I'm getting a message saying my audio and video quality may not be good. Okay, all clear, good. Okay, so the first thing that, before I go there, this is also we have seen already, but just to show you again. So these are the list of packages that are installed on my machine, and whatever is a tick mark, these are the ones that are loaded, right? We have seen this already, and now you will see RMR and RHDFS as well. Okay, so if I want to look at all the functions available in RHDFS, I can simply click on it, and it will show me a list of all the functions that are available in RHDFS. Okay, something like file copy, file directory manipulation, reading and writing files, reading text files, file copying commands. So usual file manipulation that we've seen already, right? So out of all this, there is one function that is slightly different, which is called hdfs.init. Okay, so that's the command you should first, that's a function you should first invoke before doing anything with R Hadoop. Okay, or RHDFS in particular. So what are we going to do? We will say hdfs.init. Okay, so what does it do? Essentially, it internally basically tries to figure out where is your Hadoop installed and how to execute it, and all. Okay, so before I execute anything, I would first do hdfs.init, and if you look at the help, you will see here that it initializes RHDFS package with the optional parameter specifying the location of Hadoop. Okay, so what is the location of Hadoop on my machine? It is user bin Hadoop. Okay, so that's actually set in okay, I have set this particular environment variable Hadoop_CMD. I set that to be the executable of Hadoop. Okay, so that means if I can access this particular path, then pretty much I have access to Hadoop capabilities, right? So if you, what does our hdfs.init does? It looks for the Hadoop location. And where does it look? it goes and checks that particular Hadoop underscore CMD command environment variable. If it is available, it assumes whatever is the path under Hadoop underscore CMD is the path to Hadoop on the command line. Okay, so all you need to do is set this variable once, and then you can just call HDFS.init without any arguments. Okay, without any function arguments. And internally, it looks for Hadoop underscore CMD, takes the path from that that environment variable, and then goes to that path to figure out the actual our working directory kind of thing. Okay, but if you do not have the variable set, you can provide that path as part of invocation to HDFS.init. Okay, simple, right? All we need to make sure is it has access to the Hadoop installation, either by the environment variable called Hadoop underscore CMD, or by passing in the path value to init function. Okay, so now that I have done init, so let's do the basic command, right, which is hdfs.ls. Okay, and let's give some path, user Cloudera. Okay, so just like the usual Linux output, right? So even if I do that here, Hadoop fs minus ls slash user slash Cloudera, you'd get all the files and directories under that user Cloudera, which are exactly the ones here. Okay. Now let's execute some commands, basic commands, create a directory, remove a directory, copy some data from local to file, local to remote system, and then the other way back, and so on. Okay, let's see some examples which you can actually see here. Okay, so let's create a directory, hdfs.mkdir. If I don't give slash user slash Cloudera, that's fine, because that's the home directory. Okay. So there's actually already a data folder, right? So let's look at what is there in that data folder. Okay, I have some airline data, first folder, GDP data, movie lens data, similar to the, we haven't seen that yet, we'll see it later. And then WC. So let's actually remove one of these because I'm going to create it again. So let's delete this guy, right? So how do I delete? hdfs.rm data slash WC. Okay. Actually, let's look at what is inside that folder. I have input and output. I can just remove it without any problem. Okay, that's it. So that folder is sent to trash. And now if you do ls again, yeah, you will not see WC here, right? Previously we had a WC and now it's gone because we just deleted it. Okay, and similarly I can create one, hdfs.mkdir. What is it? Data slash WC. Okay, so it created the data. Now you can again check it. Now you see WC here, the last guy. Okay, And you can start putting files from local file system to remote file system. And for that, we are going to look at, for example, um, okay, so let's say I am in this folder, Hadoop data WC on my local file system. This is my local file system, obviously, because I'm working on Linux. And it has some input, output, input 2 and stuff. So let's just copy input to HDFS. Okay, how would I do it? HDFS dot put. Okay, putting from local file system onto Hadoop file system. Okay, and obviously we need some local paths, right, and remote paths. What is a remote path? It's a path on HDFS, right? I mean, obviously it doesn't work because I gave some random text here, but this is what happens, right? So in order to give the local path, I can either give entire directory structure, or I can go into that folder also, doesn't matter. So we have Hadoop data WC input, right? That's the file we have it on the local file system input. It's just a text file. If you look at it, it's just some quotes from Romeo Juliet play. Okay. Okay. So all I need to do is execute this line, right? HDFS.put. So I can say simply run, and now it's went into HDFS, and now I can see ls. I'll see WC again, and I can see inside WC as well. It has input, and that would be the one that we just copied. Okay. Any questions? Okay. So yeah, so that's there. Again, you can go ahead and remove it, or you can copy it back into your local file system. A lot of things you can do, right? So let's do the copy back. That way we can just try Hadoop FS, Hadoop get as well, or HDFS get. Okay. So what does get take? Path on HDFS, the points to the file that we want to extract into your local file system, and followed by the local file path. So first is a path on HDFS, which is our data / WC / input. Okay, and then followed by the path on the local file system relative to the current directory. Okay. Where are we? We are in the data folder, right? So what is our get WD? Oh, we are in some other folder. But okay, even if you are in some other folder, if you give the complete path like this, it still be fine, right? So I can just simply execute that statement. Okay. So, oh, sorry, we need to execute this guy. Okay, we simply got the data from HDFS into local file system. That's all. And I just created input 2 now. So if you see input 2, it's today. Okay. Pretty, I mean, very straightforward, right? You can remove a file, you can remove a directory altogether, simple things. Okay, all it shows is you are in R, but you are running some commands and doing some file manipulations on HDFS. Okay, that's all it shows. Any questions on this? Oh, can you please show how to install HDFS? You mean our HDFS package? Oh, so I need to download the package from that GitHub location, the one I mentioned on the slide. And once you, okay, let me see if I have any notes here. Okay, so we first download these packages. I mean, do you want me to run it and show, or just the instruction is good enough? Because I mean, I already have that package installed. So you download your packages, RMR, RHDFS, RHspace from the GitHub, the location that I mentioned on the slide. And then these packages internally depend on a bunch of other R packages. So I downloaded those as well. Okay. These things you can install directly from RStudio also, that's fine as well. But here I install the source code or install from source code. Okay. And yeah, I set this bunch of commands, and then I simply have to call this rcmd install from the Windows command line. So here I go to cmd, right, the Windows command line, and then call these rcmd install if it's on Windows, or if it's from our Linux, you can type in here rcmd install the package name. Okay, and then you install all the prerequisites first, and then you install your RMR2, RHDFS, and all the other things. That's it, as simple as that. Yeah, as Sudarshan mentioned, those instructions are also actually available in LMS. It's called R Hadoop integration on Ubuntu. Thank you, Sudarshan. Okay. Okay, great. So any questions on this thing? So far so good, right? So we did basic file manipulation. Let's do one other thing, and then we'll go into MapReduce. And the other thing is how do I, so we said we can also read the data from HDFS and create a data frame out of it, right? And similarly, we can push a data frame into HDFS as a file, right? Okay, and so yeah, for that we are going to see some basic example using a particular data file, which we are going to use in the, just hold on 1 second guys, sorry. Okay, yeah, sorry, I just got the call. Okay, so Okay, so this is a data file that we are going to look at. Okay, so this is just the GDP data of all different countries. We are going to see this data again later in the context of MapReduce, but for now, just to do the example of reading and writing the data from HDFS and to HDFS, we are going to look at this data file. It simply has 4 columns, comma separated, the country code, some ID, okay, sequence ID, and the name of the country, as well as the GDP, okay, in millions of dollars. Okay, so these are all the GDP of different countries in the decreasing order, I think, but order doesn't matter. So I have this file in my local file system. So what we are going to do is we are going to copy it into HDFS and then read it from HDFS and create a data frame out of it. Okay, that's what we are going to do now. So first thing we have to do is obviously copy the data onto HDFS, right? So let's do that. HDFS.put. We can even change our directory, set wd home Cloudera Hadoop data. Okay, so I'm in that folder now. HDFS.put. What is my data file? Under GDP folder, gdp.csv. Okay, that's the local file system. And then on the remote file system, I want to again give similar path, data/gdp/gdp.csv. Okay. So this is my local file system. This is my remote file system. Okay, so it cannot find that file. Why is that? Data/gdp Cloudera Hadoop data GDP. Oh, okay. So yeah, Hadoop put does not care about the current directory actually. You just have to give the full path all the time. Okay, if you look at the help also, okay, source is the location of the file obviously, or multiple files. So you have to give the full path starting from the base actually. That's why it failed. So let's do that. Okay, now it copied onto HDFS. So we can see that HDFS.ls data/gdp. Okay, there is a file called gdp.csv now, and it's copied right now. Okay, now there are multiple ways of reading a file. A simple way, actually let's look at a very unusual way, meaning you don't use it in practice, but nevertheless it still exists, which is so in any language like C, C++, Java, how would you read a file? You open, you get a file descriptor, and then you read bunch of data from that file as characters or as doubles or whatever is your data, right? And then you finally close that particular file. That's the standard file API, right? In any language. So in a similar manner, you have here a way to open called hdfs.file command. Okay, so hdfs.file takes a path, a mode, in which mode you want to open that file, and then some default properties. Okay, so we are going to do that. We are going to open the file and then call these functions like read, tell, seek, and those kind of things. Okay, so let's do that. Let's say fd is equal to file descriptor is equal to hdfs dot file. And what is a path? First thing, we need to give path, right? And the path that we have is data slash gdp dot csv. This is our path on the HDFS, and then some read mode. Okay, that's it. I opened the file descriptor, and now I can start reading from it. Okay, so what does HDFS dot read gives us? It returns a raw vector. Okay, some raw bytes essentially. So let's do that. Raw vec is equal to hdfs dot read of fd. Okay, so this is like raw bytes, and then we can convert it into any format that we want. Let's say to characters. Okay, because I mean it's a text file, so let's look at it as a character file. So car data is equal to so this is just R function, nothing about HDFS, right? Raw to bits are characters. Let's do characters, and then you give raw vector. Okay, so that's character data. Now you can try looking at it. It looks like that. Basically, it looks at every character, right? So every /n has two things now: carriage return and new line feed and carriage return, right? So usual. Basically, it's showing every byte of your data. Okay, but this is not the way you want to see. You want to kind of make it nice, readable data frame, right? So that you can do again from existing R command, something like read table, right? So read table, you can we used read table before also, but we read from the local file system, the CSV file or something like that. But you can read it off text stream as well. Okay, and the text stream is created by something called as text connection. Again, I mean, this is an unusual way, so I don't expect you to use it in practice. Invalid text argument. Oh, okay, that's what was char data, right? Okay, so actually let's rename this. Okay, now you can see class of df is a data frame, and if you type in df, that's exactly what we want, right? Bunch of countries, their GDP in the data frame. So that's one way of reading a data frame. So just to go back, we opened a file. Okay, we can see our history. So we opened a file. We read the file as raw stream of bytes. We converted them into character stream, and using that character stream, we created a data frame, and then we have the data ready. Okay. So usually you don't do this. But nevertheless, these capabilities are available. I just want to show you what are all the things that you can do with RHDFS, right? But usually, very simple, you will call like one command, one function call to get the data into data frame. And that function is called like to DFS and from DFS. Okay, something like this. So you simply say from DFS, the path, and then you can read it as a data frame. Okay, and this function is available in RMR2 actually. So let's load that package, RMR2. Okay, so if you simply say from.dfs, actually let's look at the help if you want. Okay, from.dfs, what does it return? Returns the object whose representation is contained in the input data. Okay, so this is kind of a handle to the data, whatever it gets, and you pass that handle to a data frame. So okay, let's do that. My fd is equal to from.dfs data / gdp/gdp.csv. Okay, and so okay, from.dfs also takes an input format. Okay, or here, sorry. Okay, because since this is part of RMR2, and what is RMR2? For MapReduce, right? And what is MapReduce? You need to interpret our raw data into some key value pairs. Okay, so that's why this is and we discussed on the slide that we need something like an input format or an input reader which converts our raw data into key value pairs, right? And there are already some default input formats given to you for popular data formats. Okay, but if you want something custom, you can create your own as well. Okay, so the input format is created by make.input.format, and the output format is created by make.output.format. So let's look at this. So what does input format takes? Bunch of arguments, but more importantly, there are some default things available. Okay, like you can say text, JSON, CSV, native, sequence typed bytes, HBase, pick height. Okay, so these are the default formats that are given to you already. So you don't need to do anything. All you have to say is, okay, I want to read this data, and this data is in this format, and therefore the underlying system will know how to convert the data. Okay, so in my case now it's in the CSV format. So we just have to simply use the existing one. Format is equal to make.input.format CSV, right? That's it. It complains something. It's deprecated use of some API. So that's it. My FD is a, now if you see class of FD, it's a byte thingy. I mean, so if you see, you will see in this manner. Okay, because we said that from.dfs returns an object, okay, whose representation is contained in the input. So now if you want to convert it into a data frame, you can do that by df is equal to as.data frame of FD. Oh, is that FD or something else? That is FD. Okay. So whatever you got from.dfs is an object containing like a key value pair, right? Because from.dfs, to.dfs are the functions. They understand only key value pairs. So here it returned a key called null and a value called all this part of the data, right? So when we convert it into data frame, we take only the value portion of it. okay, because key is irrelevant for us, and you can't just take key value pair and then convert it into a data frame. So we take the value portion and say as.data frame, and now suddenly you will get df as the a data frame.